Good morning, ma'am. My name is P. Lakshman of Electrical and Electronic Branch. My roll number is 2095580 Today, my topic is about low voltage fluorescent lamp. First of all, we have to know about definition of fluorescent lamp. A fluorescent lamp or fluorescent tube is a low pressure mercury vapor and gas discharge lamp that uses the fluorescence to produce the visible light. An electric current in the gas excites mercury vapor which produces the short wave ultraviolet light that causes an sulfur coating on the inside of the lamp to glow. And a fluorescent lamp converts electrical energy into useful light, much more efficient than an incandescent lamp. The typical luminance efficiency of the fluorescent lighting system is 50 to 100%, 100 lumens per watt, and several times the efficiency of the incandescent bulbs with comparably light output. We have seen the picture, the fluorescent lamp, and the properties of low voltage fluorescent lamps. First property is they are often to take a few moments to turn on. It takes to turn on when we are on the switch, and they come in several variations of white, and they are often whiter than incandescent bulbs. They they last longer than incandescent bulbs. They sometimes humble sound loudly. They flicker before they fail completely. And seeing in color, there are a group of light seeing cone cells. We respective different colors when two or more type of cone cells respond at once. And we are observing that there are different colors in the graph which is observing in it has the pure light colors, and the left side is for infrared, and there is ultraviolet, and we have the between the red and orange color and yellow color, green color, and that we have the waveforms and the wavelength in nanometers, and we are observing the colors in seeing in the colors of three groups of light sensing cone cells. And construction of fluorescent bulbs, we have the aluminum cap and electrode coil on the glass tube, and phosphor coating and liquid mercury and cathode shield and glass stream. And fluorescent bulbs, glass tube, low pressure gas and electrodes inject few charge via temperature or high voltage form as a plasma. A gas of a charged particle's electric field produces a current flow in plasma. Collisions caused electronic excitation in the gas atoms. Some ionization of gases atoms excited atoms emit the light through the fluorescent demonstration, and observe the gas discharge lamps neon through diffraction grating and CCD and camera. We are observing the picture. In that we have the mercury vapor and the positive electrode and negative electrode. In between we have the electrons which flows. The orange color is the electrons and the green color is mercury ions. And atomic structure in an atom, that electron orbit nucleus, only certain orbits are allowed. The each orbitals can have the most two electrons in it, and orbital's energy is equal to kinetic energy plus potential energy. Due to orbital energy, we are generating the movement. Kinetic means movement and energy, and the potential means the power voltage is generated. Electrons normally reside in the lowest energy orbital. The ground states electrons can be excited to higher energy orbitals, excited states. And atomic structure, electrons is obtained by the and the emit and the emitted light when the charged bodies are active. And atomic fluorescence, excited atom lose energy via radiative transmissions, and during the transition the electrons shift to lower orbitals, and energy, the proton energy is different in orbital energies. A small energy difference in infrared photons, and moderate energy difference in red photons, and the big energy difference is blue photons, and very big difference is ultraviolet photons. Atom typically have the bright resonance lines, and mercury response like light is at 254 nanometers in the UV. And the fluorescent light starting discharge requires electrons, and heat filament can provide electrons, and manual preheat lamps initial fluorescent heating, and the automatic preheating lamps initially fluorescent heating, and rapid lamps constant fluores, filament heating. And only rapid start lamps can be dimmed. High voltages can provide electrons. Instant start lamps are high voltage pulse starts. And the fluorescent lamp gas, the gas discharges are unstable. Gas is initially insulating. Once a discharge is started, gas becomes a conductor. The more current it carry, and better it conducts, and current tends to skyrocket. Uncontrollable stabilizing discharge requires a blast. An inductor blast is 450 Hz frequency. Electronic ballast, a new and high frequency demonstration of point of ballast. And the advantages of fluorescence, high efficient energy efficiency and compacting size, having good lumens maintenance and long life, endless shapes and sizes, and dimmable, and the easy retrofit, and low operating cost, and radiate less heat. And compact fluorescent bulbs are about 4 times as efficient as the incandescent lamp. And coming to disadvantage of fluorescent lamps, fluorescent lamps are certain toxic materials, and the frequent switching results is very in early failure. Light from fluorescent lamps is in directional, and fluorescent lights emitted ultraviolet light, and older fluorescent suffer brief warm-up period and ballast or buzzer. Coming to applications of fluorescent lamps are a lamp type that is commonly used to provide the illumination for the settings such as commercial lighting and industrial lighting and classroom lighting and retail lighting. Thank you, ma'am.